Hello everyone and welcome to the second ever 3D Buzz Math VTM. For those of you who are new to this series or new to 3D Buzz in general, and would like to catch up with all the 3D Buzz happenings, please feel free to tune into our radio show offered Monday through Thursday and downloadable at 3dbuzz.com. Just click on the BuzzNet radio link at the top of the page.
Right, that lovely BuzzNet radio link. I've actually listened to a few of those shows. They're pretty good, but there's this really irritating guy named Zach who seems to just irk everybody who listens. So how's everybody doing? Again, this is the second lesson on the Math VTM series brought to you by 3dbuzz.com. My name is Zach Parrish. As most of you know me on 3D Buzz as Dark Viper 338. And with me this evening is my very good friend, Mr.
Rob Rolnick. Most of you know me as Demondo on 3dbuzz.com.
Which is what we're going to keep calling you all through this. And Demondo is once again going to be your personal guide into the deep, dark, scary world of mathematics. And he's going to be covering what we're lecturing over tonight, which is a bunch of cool stuff, but I think I'll let him do all the explaining in that regard. So what are we talking about this evening?
Well, this evening we're going to be talking about variables and solving systems of linear equations.
Sounds fun.
But before we get into that, before we dive in, I'd like to offer a short errata for the first VTM.
An errata?
Yeah,
Ooh.
I goofed.
And by the way, errata is just a fancy way of saying, oh, excuse me, we screwed up, thank you.
As many of you pointed out on the site or through my email, there was a mistake on this very slide in the first lesson. Namely, we reversed the greater than and less than symbols.
Now, don't reverse them again when you're trying to make up for it.
I'll try not to. Greater than should look like this, and less than should look like that.
Yeah.
As Zach pointed out to me when he noticed, it's supposed to be alligator mode.
Actually, you made the mistake when you put the slide together, and then I just walked headlong into it, and I just went right on and kept right on going. So show them what the number line would look like with a greater than 1 on it.
Okay, if you wanted every number greater than 1, or every real number greater than 1, you'd have a 1, and you'd say every number greater than 1 would look like this.
Oh, yeah, he got it.
Almost screwed up again.
Yeah,
you saw that pause.
I watched where your cursor went, and I was like, he's going to do it again.
But no, so you'd have like every real number, remember the double struck R, greater than 1. And you'd make the little empty circle here, and it would be everything.
Color everything else in. So that was your errata, which is our way of apologizing, saying, oh, we made a mistake. So with that, we can get right on into the meat of our lecture.
Exactly.
So what else are we talking about this evening, other than how we messed up the last video?
Well, we're going to introduce our viewers to variables.
Variables. Ooh, scary, freaky. We're starting to put letters into our math equations now.
Right. You might remember there were some variables in the first lesson, but we didn't really explain what they were. We just kind of threw them in and said, don't worry. So now we're going to actually explain what a variable is, when to use it, how it's useful, etc. So a variable is a symbol, frequently X, but it can be really anything. It could be a Greek letter. It can be pretty much any symbol you'd like.
Doesn't X always equal 24?
Only in your world.
Oh, come on, that little decoder ring that assigns a number to every letter of the alphabet. Never mind. Okay, so it's something different each time. Very cool.
Right. So in this example, right there, x plus 5 equals 10. You might notice that if x was 5, then 5 plus 5 is 10.
Gotcha. Cool.
A variable does not have to be a single letter. It almost always is. It's shorter to write a single letter.
Of course.
But if you wanted to say Fred was your variable, you could say Fred plus 5 equals 10.
Wow, yeah.
And then Fred would be 5.
So you could have a long time ago in a galaxy far, far away as your variable?
Yeah, you generally want to avoid the spaces, but if you put underscores, yeah, it would be fine.
Wow, that'd take a long time to write. All right, continue.
Right. The value that a variable represents may change between problems, but within a single problem, it is fixed. So, for instance, if we had in this example, if we used the same x as the previous example, and we said something like x plus 5...
I'd like to just note for the record that Demondo is writing with the mouse because he has a psychological aversion to writing with the Wacom tablet.
Yeah, I do. X plus 5 plus x equals 15.
So if you're wondering why his handwriting is so bad, it's because he's using a mouse. And actually, for mouse writing, that's not bad.
Hey, my hand is just as bad when I'm using the Wacom.
Okay, just continue.
In any case, you'll realize that x plus 5 plus x is 15. Just like before, if x was 5, you'd have 5 plus 5 plus 5 equals 15.
Sure.
But let's say I had a different example, and I had x plus 7 equals 10.
Ooh.
That's a 10.
Yeah,
Then
it's like 11 for a moment.
It did. In this case, x would be 3.
Yeah.
So within one problem, x is constant. It's always 5.
Right.
But it can be different in a different problem.
Cool.
Next, when solving for multiple variables, you need a minimum of one equation per variable. So there's two things to explain here. One is, why do I say minimum? Well, the reason I say minimum is because if you had 3 equations, but through manipulating 2 of them, you could generate the third, and I'll explain how later, don't worry just yet. Then your third equation, since you can generate it from the other 2, isn't telling you anything new.
I gotcha.
And therefore, if you had 3 variables, those 3 equations won't let you solve for all 3.
All right.
And the other thing to explain is why I say you can only solve for one variable per equation. Well, look at this example. We have x plus y equals 7. Well, if you're solving for, let's say, y, you could say something like y, that's a horrible y, equals 7 minus x. But you still don't know what x is, and then you don't know exactly what y is. So I'm going to break into Photoshop right now and show you that if you solve for it like that, you'd end up with a line of possible solutions.
Ooh, you're going to show us how to graph a line.
Right.
Gimme.
Our equation is x plus y equals 7. And we're now in Photoshop, and I'll try to use a Wacom.
Picking up the Wacom stylus.
Math sphere.
Tearing up.
So as we
proud
said,
moment for me.
Y equals 7 minus x. So if we draw a quick Cartesian graph, so basically an x-axis and a y-axis, which I'm drawing out of order.
Back down, actually.
Yeah, I put it down. And so now we have our x and y axes. And we know, let's say we want to plot 1 point. Well, we know when x is 0, then y is 7.
Now, guys, it should be noted that we are assuming you have a general understanding of the x and y grid.
Yep. So the vertical would be y, the horizontal would be x. So as I was saying, if you plotted y is 7 when x is 0, you'd have a point right there. That being the point 0, 7. And then you might want to plot another point, say when x is 7. And these aren't drawn to scale, I should point that out right now.
Sure.
You'd have a point right there, which would be 7, 0. Because if x is 7, then 7 minus 7 is 0.
Right.
And as you plotted all the other points, you'd get a line that would go exactly through there.
Oh, go ahead and see if you can draw one.
With my hand?
I challenge you. Do it.
Okay, we'll try. That should be straight. It's not exactly straight.
Right, but we get the idea, because you could just keep right on going.
And that would be the line y equals 7 minus x.
Groovy. That is awesome.
Right. So, as you can see, with 2 variables and 1 equation, you can solve for a line of possible solutions, but not a single solution that satisfies both x and y.
Sure. Very cool.
So, nuke this and jump back into PowerPoint. So, and finally, the final point is that sometimes multiple values may satisfy a variable.
Gotcha.
So, in this example, if you had minus 9, or if you had 9, both would satisfy x.
Right, because negative 9 times negative 9 is going to be 81, same as 9 times 9.
Right, exactly. So, if you were solving that, you could say that x equals negative 9 or 9, but not that x equals negative 9 and 9,
right,
because it can only have one value.
One or the other.
So moving on, single variable linear equations. I should start by explaining what a linear equation is. Say you had an equation that had x's, y's, z's, any other variables you wanted all in there.
Sure.
All it's saying is if it's linear, all those variables are to the power of 1. So you won't have an x squared or an x cubed, everything is to the power of 1.
All right, cool.
So anyway, when solving single variable linear equations, the goal is to isolate the variable on one side of the equation. This can be done using the following steps. So you can you usually do both the steps. You collect all the variables on one side of an equation and all the constants on the other. We'll show you how to do that. and you divide both sides of the equation by any coefficient in front of the variable. A coefficient is, for example, let's say we had 7x. X is your variable and 7 is your coefficient. It's the little number in front of the variable.
Sure.
So, examples. If we'll pick 2 of them and solve them live.
Okay, cool. Well, x plus 7 equals negative 3 is real easy. I mean, you can almost do that in your head, so we won't really worry about that. So let's take a look at the second one down, which is 5x minus, and then in brackets, 2 plus 7x equals 12. How would we solve that?
Okay, so we'll jump quickly into Photoshop and work on it. You have 5x.
Mm-hmm.
I believe it was minus 2 plus 7x.
If it wasn't, we'll just solve this now.
Right. Equals 12.
Okay.
So the first thing you do is you recall from the first VTM lesson where we said that the distribution law, distributive law. So you'd say this would be minus would be equivalent to minus 1, and you distribute that. So what you say is you'd say plus, and you'll distribute, and you'll have minus 2 minus 7x equals 12.
Mm-hmm.
And then you group your variables on one side, so you'll have 5x minus 7x. And you want to put all your constants on the other. So you could do it one of 2 ways. You could say that adding the same thing to both sides of the equation doesn't change it.
Sure.
Or you can say that if I want to bring minus 2 to the other side of the equation, I just change the sign. Which is essentially saying if I added plus 2 to both sides, the minus 2 plus 2 becomes 0, and the 12 plus 2 becomes 14.
14.
So we'll just say that. 5x minus 7x equals 14.
Okay, cool.
And then we say, well, 5 minus 7, I know that's minus 2, I hope, equals 14. And assuming I solve this correctly, x equals minus 7.
Seems right to me.
Because I divided both sides by negative 2.
Sure.
So that should be right. If I made a mistake, I apologize in advance.
We'll have another errata.
Yes, we shall. And now we're going to solve perhaps the word problem, I guess, live.
Go for it.
So we'll just jump back to PowerPoint and read the word problem.
John is twice my age. Together we are 57 years old. How old am I?
Right. So let's say I had a friend, John, and he was twice my age. So we'll say my age.
He put an underscore in.
Equals
That's awesome.
X. And John's age, I hope I spelled John's right.
Close enough.
Age is twice my age, so he's 2x.
All right.
Together, we are x plus 2x, and we're 57 years old. 57.
Looks good so far.
So how old am I? Well, we need to solve for x. So we'll say 3x by adding x plus 2x equals 57. And dividing both sides by 3, you get x equals 19 years old. Horrible cursive, but years old.
That works. So you are 19 years old, and your buddy John is 38.
Exactly.
Cool. I like it.
So now that you know how to solve systems of linear equations in one variable, we'll move on and talk about systems of linear equations in multiple variables.
All right.
So systems of linear equations basically means you have several linear equations. So not 1, maybe 2, 3, 17, it doesn't matter.
Gotcha.
And when solving systems of linear equations, you start basically the same way as before. You put all the variables on one side and all the constants on the other. And then you can solve the system using one of the 2 methods outlined below. There are others. We might talk about others later, but for now we'll stick with these 2 methods.
Okay.
The methods are addition and elimination, or substitution. So, addition and elimination is really, really simple. Zach can read the slide.
Okay. This technique involves multiplying an equation by a constant, and then adding this new equation against the other ones in order to reduce the number of variables present. Right.
So I'm going to jump to Photoshop and use this example to show you how it works.
Gotcha.
So we had two systems, we had two equations in our system of linear equations.
Right.
We had 4x plus 2y equals 5. Wow, kind of lopsided. I'll just fix that. There. 4x.
Look at you.
Plus 2y equals 5, as I was saying.
Gotcha.
And 2x minus 4y equals 9.
All right.
So the goal, of course, is to solve for both x and y.
Mm-hmm.
So what we do is we can do it in many different methods. I'm going to do the first thing I'm going to do is say, hey, we've got a minus 4y here.
Right.
So if we had a 4y, positive 4y here, and we added, we'd have 0y.
Sure.
So I'll start by multiplying the first row by 2. So if you multiply the whole first row by 2, you'll get something like this. 8x plus 4y equals 10.
Gotcha.
Because you just go term by term and multiply by 2.
So you haven't really changed anything.
No, because if you divide it by 2, you'll have the exact same thing you had before.
Sure.
And now we still have the same second equation. Minus 4y equals 9.
Mm-hmm.
And now if we would add the 2, so we're just going this side, we're essentially adding them separate. So imagine if you add all this side,
right,
and then you'd add all this side.
Okay.
So you'd get 10x plus 4 minus 4, so that'd be 0y,
right,
equals 19. X equals 19 tenths.
Gotcha.
And then once you know this...
Or 1.9.
Right. 1.9 equals 1.9. Once you know this, you could solve the other one using a similar method, or you can do something else, which is what I'm going to do. I'm going to say, we know that x equals 1.9. Mm-hmm. So 2 times 1.9, basically I'm plugging x into this equation here.
Sure.
That one right there, if you can follow the cursor. Minus 4y equals 9. And now it's getting really messy, so I'm just going to jump up here. And we'll have 3.8, I believe.
Mm-hmm.
Minus 4y equals 9. 9 minus 3.8 is 5.2, I think.
Mm-hmm.
So minus 4y equals 5.2. And y equals minus 5.2 over 4. And I'm not going to, but if you wanted to test that this makes sense, you could plug both of these values into the first equation and make sure it works. Because it should work in the second, because that's how we used to solve it. So if you plug into the first and you get 5, if you plug x and y in, then you know we solved properly.
Gotcha. Very cool.
Okay, so that's the addition and elimination method. You'll see how we added two equations to reduce the number of variables by 1, by getting rid of y.
Right.
The other option is substitution. The trick in substitution is that you solve for, let's say, y, and then you plug whatever y is into the first equation.
Okay,
or
cool.
second equation, depending on how you solved.
Sure.
So these are the same equations as last time, and hopefully we'll get the same results.
All right, cool.
If we don't, we'd screw it up somewhere. So jumping into Photoshop, we'll show the substitution method now. So again, our equations are the same. 4x plus 2y equals 5, I believe. And 2x minus 4y equals 9. So you can solve for by isolating either x or y. I'm going to say that I'll isolate x, I guess, in this equation down here. In this one, we'll isolate x. So we'll get 2x equals 9 plus 4y, because we added 4y to both sides.
Sure.
And we can divide everything by 2 to solve for x, or we could simply say that 4x is 2 times 2x equals 4x.
Ooh.
So I'm going to do that.
All right.
And then say that we know 2 times 9 plus 4y plus 2y equals 5.
Gotcha.
And then 18, because 9 times 2 is 18.
Yeah.
Plus 8y plus 2y, so I'll just jump a step and go 10y equals 5. Then 18, I'll do it like that. 18 minus 5 is 13 equals negative 10y. So basically I just brought this over to the other side, the 10y over to the other side, and the 5 also over the other side. And then we know that y equals negative 13 divided by 10, or negative 1.3.
Yeah, which is the same thing we got on the other side. We just didn't take it to that final step.
Right.
Very cool.
And using the methods we showed prior, you can now solve for x. We're not going to do it again.
Right, exactly. Very cool.
And although it's been a short lesson, that's the end of this one.
Cool.
And here are some examples for you guys to practice with.
All right, so yeah, just pause the video, jot those down, and see if you can't churn those out. So with that's going to wrap up this video. I'd like to thank everyone for watching, and thank you, Demondo, for all of your work.
No problem.
That'll be it.
Thanks a lot, guys.